Thanks, guys. Thanks for putting us on. Everybody appreciates it. I know, like you said, PD training right now is extremely important, and so I'm not going to take up any more time with that stuff. I'm going to kick it right to my colleague Tim Dwyer. If you don't know Tim Dwyer, I'm sure many of you on here do. He has been at the Colorado Auto Teachers Conference more than once. Tim is a former college level automotive instructor. I guess he's always an instructor, not former. He's always learning. Tim is passionate about education. He is a member of the Skills USA committee as well, and so he's extremely passionate about Skills USA as well. He is going to be presenting to all of you kind of a virtual way or a limited way to present what happens when your check engine light is on in automotive service technology and teaching engine performance from a distance. So with that, I'm kicking it right to Tim and I'm shutting up.
Okay, good morning. I'm going to try and share my screen. We'll see what happens here. I'm kind of the taking the virginity off of this platform here. We haven't tried it before. I need your eyes, Jeff. Can you see that beautiful Z car?
It's in the queue. We see your face right now.
Okay.
Rick will.
Let's do this. And when I'm up there, you're going to be able to see my face, or the attendees will too, also. Yes, no, maybe.
It depends on what Rick sends live. So right now we don't have your face, but when we get your PowerPoint up, we can put your face to the side of the screen.
Okay. Well, my PowerPoint's up. I should be sharing my screen. I'll let the Wizard of Oz take it from here as far as what everyone else sees, and then when you're ready, just say.
You're ready.
Okay. First of all, I really appreciate this opportunity to help you all teach technology in what I would consider a very difficult time. While everything is changing, I think there's probably some advantages to the new technologies that we're all having to learn. I think there's probably going to be some residual carryover to when we do get back on campus or in classes. I think there's really an advantage to preparing students this way. And so I don't want to come off like we know everything here at ConsLab. We kind of got thrown into the mix back this summer when the COVID shutdown happened. We stepped up and decided we were going to try and provide webinars to help instructors. And we kind of learned how to do this in front of a lot of instructors, and we made mistakes and we had victories. And so I think you need to be encouraged by the fact that no one knows how to do this exactly. This is a different beast all the way around. I'm a pretty firm believer that CTE is real tough to teach virtually or from a distance. Eventually the students have to come and show what they can do with their hands, and they want to. They don't want to do it virtually. So we have this little abyss here that we need to kind of bridge. And my thinking is that what I'm going to try and help you with today is better preparing students to come to campus, or actually having them come better prepared, so that the time they spend, and if it may be on an individual basis, it may be in limited numbers, but the end result is the shorter amount of time that they're going to be in your shop or in your classroom is time better spent because they come prepared. So some of this distance and virtual learning can, I think, corporately bring them together to where they're kind of chomping at the bit to get back onto campus, get to a vehicle and actually try their newfound powers. So I just can't imagine, as an instructor, how hard it is going to be to teach CTE in this environment. But I do understand that it's not going to be easy, and we're going to try and help you here with some ideas this week. We've been doing some of these sessions this summer, like I said, on our webinars. We did a conference last week in Florida. I did the same presentation to a group of teachers in Texas last week and had a really good time with it. Jimmy was trying to explain a little bit earlier that this platform, due to the numbers of who we're talking to today, this platform's a little different. I kind of thrive off of interactivity. I like feedback. I need body language, and this isn't going to happen today. So I'm going to have to kind of role play a little bit. Normally I would stop and ask and wait for the chat, and we would address. I would let you drive the direction of my presentation. We're going to diagnose a check engine light today, and with this platform, it's not going to happen. I mean, as far as your input, there's still question and answer capabilities, and we'll deal with that probably more at the end. But for right now, I'm probably going to ask and answer my own questions, and we're just going to kind of show you how, or illustrate how how I think it could happen in your, I guess, with your class. And I will say, last week, this is kind of the opposite of last week. I did a deal in Texas, and there was 20 instructors, and we opened the microphones and had a very, I think, great discussion where I would stop. I would ask for a response. They would give me a response, and I'd go back and forth in my presentation and find what they wanted, and we would re-illustrate, analyze it. We had a really good discussion, and that was how I hope it would work in your classroom. So I'm going to kind of try and probably demonstrate it more today than let you all participate, but I think you'll get the idea. So let's see here. I think you're going to hear me say drop and anchor a lot. I call them anchor points, where we just stop and discuss. And so I'll be discussing amongst myself. Okay, first of all, we have a deal where, like I said, this summer, and you all are having the same experiencing the same thing right now. You have to work with what you have, okay? And so when we first started doing these webinars, I was a little cautious, because we're on the education team, and I didn't want to come off like a salesman. But in reality, we have our equipment in our hands here, and that's what we had to use. And for the most part, it works really well for us to demonstrate how to teach from a distance. I don't have hands on this engine bench that we're going to use today. This summer, I kind of virtually did. Our boss, Kevin Bowden, went down to our offices in Quebec City, and was my hands. I was able to remotely work the scan tool, and it was really kind of a cool little interactive time. The Canadians are on vacation this week, so there's no one at the call up the mothership. So what we did is, some of you may know Nathan Banky with ConsulLab. Last couple of weeks, we've been sitting there and actually trying to film. Do short videos of any, I guess, a path that a diagnostic discussion would take us down. And so I've got all these little videos in a queue here, and we're going to kind of go through a process. What I'm trying to do is teach you how to, or show you how to teach from a distance, but I'm also trying to instill upon you maybe my own philosophy on how a student should be taught engine performance. Because I listened to our advisory committee when I was teaching. I taught for 12 years, and I had a shop for 25 years. I kind of have an insight on, I think, what I want in my shop working as a technician. So how they go through the process they go through to diagnose something, I'm going to show you. The process of doing this from a distance, I'm going to show you, and then you're going to see it on our engine bench, which there's some cool features on this bench, and I'm going to show you as we go along. My hope is if I don't ramble too long and we get to the end, I can pull up this new feature of how we insert case studies into this engine bench, and show you as an instructor how easy it is to have student-led and instructor-led moments with this bench. So having said all that, hopefully you see my first slide, engine performance, a campfire teaching technique. And I call it that because I think if this was in a situation where we were in a classroom and I had an engine bench, it would be a campfire. We would all gather around it. I would probably hand Johnny, the keys and a repair order, and say, here's the customer concern, and let him go through, and I would want to watch his process. Hopefully, we've talked about it enough to where when you got to the bench, he has some type of a strategy. As he proceeds on and does anything from putting the key in it to putting the scan tool on it to whatever test he chooses, I want to question him. Everyone else in the campfire kind of has to be quiet and let him on his own. If he gets stumped, backed into a corner, whatever, he can phone a friend, he can bring a guy in or a gal in and actually ask them for their opinion. And they might say, I think you probably should have checked this back here, or you should have disturbed this, or whatever. So corporately, it's a rich environment to get many thought processes involved into training them how to think. And it's just like all our tech hotlines and stuff too. Everybody gets on there and throws a problem out, and everybody kind of dog piles on it and tries to solve it. So picture campfire, picture this engine bench. I used to tell my technicians and really my students probably more that, the big responsibility when you're handed the keys in a repair order, you're on. It's not walking out to the car on your phone, talking to your girlfriend or your boyfriend or whatever. This is a responsibility. You need to be observant. You need to know what you're working on. You need to study up on the systems you're working on, and you need to be observant from the second you get the keys to as you walk out to the stance of the car, to, are there leaks underneath the car? How do they take care of the car? I mean, does it look like it's even maintained, or have they probably neglected it? And things like that. So we're going to start kind of the same way. Today's patient is a 2014 Hyundai Accent. It's got a G4 FD engine in it, which in I guess Korean is a 4-cylinder with a GDI fuel system on it. And it's a manual transmission car. So let's get familiar. Here's going to be the first video. It's either going to work on this platform or it's going to choke out, but I'm going to wait and I'm going to play it and kind of watch Jeff's face here and see if it's even legible here. So let's get to know this bench.
So let me introduce you to this Constellat product. It's an engine bench, very similar to ones that we've had in the past. However, there are a few differences. I mean, it's still got 4 wheels, it's still got an engine and a lot of the same features, but really the entire area here where the rubber meets the road, where the instructor, you or the student interacts with the product, is totally different, totally redesigned. So we no longer have a fault box underneath. We've still got the instrument cluster. We've got a redesigned breakout box. We've got now integrated data link connector breakout box. The data link connector is right up front and center. Ignition key. You got a special switch I'll talk about later right here. And now you've got this student learning platform. And we'll get into the details of that after. Now, down at the front, we've got the fuel system, gas pedal. We've got the battery. It's got an integrated battery charger so that you can leave it plugged in. A main battery cutoff switch with a spot to lock it with the padlock. So you can lock it out, tag it out. Still got the cooling system. Of course, this is a GDI engine. Lots and lots of access around the front of the engine here. Around this side, you can see we've got the exhaust, ignition coils, all that jazz is there. Everything's nice and easy access. We've got the fuse boxes right next to each other, and you can see the evap system down there. So that gives you a pretty decent overview of the engine bench.
Okay, part of, I think, being observant is, just like I said, when you walk up to the car, they should be observant of everything. When they get in the car, and I think this is kind of an overlooked area, is that they don't always practice looking at what dash warning lights are functioning. The bulb check that a car goes through when you first turn the key on before you start it. It runs a test and checks all the bulbs. And so I'm really adamant about that they watch that like a hawk. So I'm going to take you there, let you watch it like a hawk. I want you to look at it and get familiar with the instrument cluster on this.
We'll just see what it's like. Known good. Coming up to 10. It's running beautifully. Runs perfectly.
Okay, so that's a known good. I like them to know, what the engine sounds like too. I want them to see, again, the instrument, the dash warning lights. I want them to be oriented and know that what lights are, I guess, applicable to what I'm doing or what we're going to be doing here today. And as you saw in that last little video clip, there's some lights that are going to be on that relate to modules that are not on this bench. I always kind of joke and say our engine benches, the VIN number died and donated its organs to this bench. But again, we don't have airbag and ABS and traction control. So those lights will have they'll still be on. and usually because, like I said, because there are no modules. The one I want you to be real, I guess, observant of is this one right here. I want you to know where the check engine light on, because that's the name of this particular session. How do we diagnose a check engine light? Okay, so in the same vein of going, I guess, knowing good, I want the students to know how to verify. I want them to verify scan tool communication, and I want to make sure that there's no codes before we start diagnosing a problem on this car. So here.
All right, so let's go through, looking at the scan tool for the engine training. We'll take the dongle, plug it into the DLC. We'll see right off the bat, as soon as we turn the key on, we've got communication going on there. You can see that through the DLC breakout box. We're gonna go in quickly. We're gonna go automatic selection. We pulled up the VIN. We're good to go. We're gonna go in with the North American car. And we'll do two things. We'll pull up live data, and then we'll take a look at the codes. So we're gonna go into diagnose. Control unit, pull up the engine control unit. Pull up some live data. And we're in. So we've got live data, all the different values. We can see the coolant temp, we can see the target idle, we can see system voltage, everything else. Once we fire this up, we can get all kinds of live data out of there. We can also get trouble codes. So let's see if there's any codes in the system, see if the last guy, hey, look at that, the last guy did his job. We're all clear, good to go.
Okay, so from a student point of view, now they know known good. They know what the engine bench is like. They know what it sounds like when it runs well. They know how to hook up a scan tool, and they know that it can communicate, and there are no codes already. So now we hand them the repair order and say, customer concern, engine died and restarted, but has an extended crank. Unfortunately, as technicians and teachers, we kind of have some experience baggage that we carry with us, and a lot of times that statement right there might rule just a ton of stuff out. We already know I'm not going to look here, here, here because it wouldn't cause that. This is my guess. I'm going to start looking in that direction. We can't expect our students to have that, and you know, at a high school level, or you know, even at a college level, they haven't really sometimes developed that diagnostic strategy. So where they go from here is somewhat coached, but I want them to do it on their own. I want them to follow the data, I guess is what I'm trying to say. So let's first of all, pretty adamant about, you know, if we in a dealership environment, I think they teach you that, you know, the 3 C's that you confirm the customer concern first. So I urge my students to kind of validate that. Okay, so extended crank did start. So let's take a step back, put our teacher's hat on. I'm going to show you something real quick, and the question would be maybe from you, and this is the start of, you know, and it's not a sales pitch. I just think this is cool. And as a teacher, this is how I would want to teach it. I love these engine benches because we can control a whole lot of stuff. So how did we make that happen? I'm going to show you just really quickly, and then we're going to continue on.
All right, so I'm going to fire up the engine, and then I'm going to insert case study 02, and we're going to see what happens. So I fired up the engine. We've got no check engine light. It's running beautifully. We're going to go in the student menu. We go to case studies, case study 02. Check engine light on, extended crank. We're going to press start the case study. Boom. It stalls. What just happened? We don't know. Okay. So now let's try and crank it. See what happens. That's an extended crank. So if we look over here, do we have a check engine light? We got no check engine light. Okay.
And this is where I would stop and quiz the students, just as a drop anchor moment. You know, there's a kind of customer complaint. We've experienced audibly and physically, we hear it crank very long and then start up. Why wouldn't there be a check engine light? And for the most part, a lot of times they don't know. So I would say just that. Why no check engine light? And my hopeful response would be this.
Let's do a second ignition cycle. So we'll shut it down. We've still got the same problem. It'll be another extended crank. We'll see what happens. Now what happened this time? This time we've got a check engine light. So we probably have a clue, probably have a code, and that could lead us down a path.
So class, what's the next step? We have a check engine light. What are we going to do? And that's where they could put in multiple answers, but I'm looking for, let's put a scan tool on there and see what the code is.
So if you have questions, I am monitoring the chat.
So they can't ask questions? Okay. Well, let's have Nathan hook up a scan tool and see what we get.
So now let's go in, grab the scan tool to pull the codes, see what we get. So we've still got the case study in. Fire up the engine, come out of here, we'll go trouble codes. Boom, we've got a P0335 crankshaft position sensor A circuit code. It's active. So now your students can go through using whatever service information you've got and diagnose and find that problem.
Okay, I don't know how you all teach, but the next step for me, I mean, I would ask them just that, what's the next step? What turned the check engine light on? What does the computer want to, I guess, see that made it not happy and turned the check engine light? Or throw in the big word, the enabling word. What's the enabling criteria for a P0335? And that's where we force them back to the book, the service information, whatever, however you, I guess, whatever system that you have in your classroom. But I pulled it up here and ran through the description for them. Okay, it's a crank position sensor, is a magnetic type sensor, generates a voltage using a sensor and a target wheel. There's 58 slots on the target wheel with one longer than the other. When the slot of the wheels aligns with the sensor, the voltage is low. When the metal tooth aligns, the voltage is high. So now we understand we're seeing a voltage change with this revolution of this sensor. And I'm kind of being generic, but that's, like I said, they don't have a lot of experience yet, so they can't really picture this. During one crankshaft rotation, there's 58 rectangular slots and one longer one. That's how it dictates where top dead center is and uses it for timing. So, but none of that answered the question I'm asking, and it's enabling criteria. And so down here in the second little bit of information, it says, unless it sees a reference mark on 2 or more times during cranking, if it doesn't see that reference, it's going to set that code. So we know now that the engine has been cranked over at least twice. It hasn't seen the signal for some reason, and so it's turned on a check engine light. Fair enough. So now, just for fun, I always kind of like to play with them and say, well, let's look at the code and what's the, what travels with that code? I mean, what could cause that in addition, or what could cause that computer not to see that signal? And so the 0335 alone, it can be 4 different things: the crank sensor, the computer itself, the crankshaft. Seems kind of harsh, but I guess a possibility, because it shows over here on the column on the right that it's happened at least twice according to this tech hotline. Or cam position sensor. And then the fact that we just have one code is important. We drop anchor and talk about that. And what if it had a 335 and a 336? Which one do we address first? And the idea, or the illustration here, shows that if it had 2 codes, then it almost narrows it down to the cam or crank sensor. And we discuss this. And I don't, you know, if this was a more intimate setting, I wouldn't be doing the talking. You guys would be. So I stop and say, let's back up real quick. I've been kind of harping on you all to be very observant, you know, from the minute you get the keys until the dash warning lights and whatever. What other observations have you noticed? You've heard it, extended crank, you see a check engine light. We know we can communicate with a scan tool. What else did you see? And I say, well, let's look at, I guess, a common list of symptoms that travel with that code. And so I see, you know, all these on the left. Engine doesn't start. It does start. Engine starts hard. Yeah. Runs rough. Stalls and idle. Doesn't seem to do that. Engine oil pressure lights on. Well, I can't say I noticed that. I might need to go back and look. Engine hesitates. Didn't seem to. Engine lacks power. Well, we can't drive the engine bench, so I'm not 100% sure there. Engine stalls and does not restart. We didn't really experience that. Tachometer inoperative. I don't know. I might have missed that. So I turn around and do this. I go back, kind of jump in here and see if we can catch it.
This time we've got a check engine light.
So I got it to the point where he started it up, and now we have check engine light, but look to the left there. That engine's running with the check engine light on, and we have no tach. So my hope is that they caught that, and not necessarily me, but if they had a question about it, I can go back and show them. Okay, so before we proceed, let's see what's going on here.
And here we've got the scan tool set up. We're watching the engine speed. We can see it. Speed changes. It essentially is the same as the tachometer over here on the instrument cluster. And if I put in the case study and we fire it up, it's going to be a long crank. We still have engine speed. Now we have engine speed on the scan tool. So what do we have over here at the instrument cluster? So one of these two is a little bit smarter than the other one. Still getting a speed.
So now we drop anchor here for a moment again here too. And this is where I'm going to kind of role play here a little bit. I'm going to say, how can we have a signal on the scan tool, an engine that starts and runs, but no tachometer, and a crank position sensor deal? So I'm going to try something here. So Mr. Dwyer, I think maybe the scan tool's smarter than the car because it's getting some kind of signal from somewhere, but I'm not really sure where. So then we sit back and talk about what else could it get a signal from? I don't know, maybe it gets it from the other sensor, that other guy, the cam sensor. So the discussion goes toward, it's totally a discussion. I mean, it's a campfire moment. They start realizing that maybe both sensors don't have to work for the engine to run, and why would that be? Why would an engine run with just one sensor, and et cetera, et cetera. So we dropped anchor and we've blown this thing up. This lesson I'm going through in an hour here today could be almost a week-long discussion. So, and my hope is that you savor those moments when they do start asking questions. Okay, so let's try this. Okay, so where do we start? Where do we start this diagnosis? And my best student would come back with this answer. Mr. Dwyer, you have always told us to start at the battery. We can't diagnose any kind of electrical, electronic, or no-code drivability problem unless we have a good battery. Fair enough? Pretty clunky, huh? So let's start at the battery. I'm proud when they remember that, to be honest with you.
All right, so let's check system voltage and also see what the charging voltage is at with the engine running. So we've got a couple options. First, we'll turn the multimeter DC volts. We'll set it down here. We'll go down to the battery, and we've got 12.7 volts. And if we come up to the DLC, we've got 12.7 volts. If we fire it up, you can see voltage drop while cranking. Now it's running, voltage is coming up, and we're up there right around 14 volts. Beautiful.
Yeah, I'm happy with that, and I'm happy that they remembered to always start with the battery. So I think it's important to take them around and show them the neighborhood. If we're going to be diagnosing something, I think they're all kind of chomping at the bit to figure out what's going on with this crank sensor. And it could be something as simple as it's not plugged in, you know. It could have been driving down the road and run over a cardboard box and it flipped up and pulled the harness apart or something. So let's what does it look like? So I had them pull it up, service information, and tell me what we're even looking for. What does this beast even look like? Where is it located? You know, they've got a picture and service information. It looks like it's, to me, a bell housing, not the front of the crankshaft. So it's probably at the rear of the engine. And then since we're working on this Hyundai, I'd go around and actually find it and pull the harness and pull the connector and show them we can find the connector here, but the sensor's kind of buried. So, but at least it's plugged in. And so now we can kind of proceed on. And just like anything, you know, we don't drive anywhere without our GPS. If we're going to go look at this crank sensor system, let's kind of get oriented on what the map looks like for the wiring, okay? Because it is an electrical sensor. Pull up service information. Hyundai uses this, I guess, not a code, but it's a label of EGGM-KG for one side of their computer harness. You'll see it on our breakout box. Everything on our breakout box mirrors factory service information. The side with the crank sensor, I guess wiring to it, is the KG side. And then the little MT, I don't know if you can see it or not, is denotes a manual transmission. So there's difference in automatic and manual. Again, more good discussion. They need to totally understand that. So service information that we have built into that student learning platform, the little tablet that we started showing you at the beginning there, has access to this picture. And I have them pull it up and I circled the EGGM-KG so that they know they're on the right part of the computer. And then the crank position sensor is there on the right side, and it has two wires coming out, a brown and a white. Goes to connector, and we're going to call it KG89 and KG67. So now we're kind of know what the neighborhood looks like, and we're going to go from there. So let's review. What do we know for sure? We know the engine starts and runs. We know it cranks a long time. We know that the scan tool does communicate. All those give me good clues. The check engine light's on. It's got a PO335 crank position sensor, and we understand what the computer wanted to see, wasn't happy with, and turned that light on because of it. So it's a two key cycle scenario. We know the tach isn't working. May or may not be related to the same problem. We don't know yet, but we think so. But the ECM still sees the speed signal from the engine, and then we now know where the crank position sensor is. So let's look at this. This is where I wanted to kind of let the class drive this thing. And I would say, where do we go? What's the first test and what's your expectation? And since this is kind of driven by me now, I'm going to kind of run down the list here. I kind of feel like it's probably, I don't know, maybe the way I would do it on a car. I don't know that I'd jump to a scope unless I'm really comfortable with it. But I've got ways to illustrate all of these. And as we go through here, we'll see if we can figure out what's going on with this. So measuring voltage, let's, you know, I would ask my students why, what kind of voltage, AC or DC? And they would say, well, we didn't think cars had AC, probably DC. We're thinking Mr. Dwyer is trying to trick them. And he did, believe me. So, but let's measure DC voltage first.
So we've already inserted the case study. We fired it up, had an extended crank. We did that twice. We got a code, we got a clue. So we got a P0335 crank sensor code. And right here from the case study, we can get into wiring diagrams, breakout box. We can just get some information here. Again, your students can go through the diagnostic procedures in whatever service information you give them. We'll go to the crank sensor here. So we've got a brown wire, that's a crank sensor signal, pin 89. We've got a white wire, crank sensor ground, pin 67. Let's just quickly see what we got there for voltages. So I'm going to grab my multimeter. Just going to put one of them on ground. Again, we've got ground at the DLC, and we can make sure that that ground works because we've still got system voltage, so we know our ground is good. If we go to pin 89, we turn the key on, we got 2.5 volts. If we go to pin 67, we get 2.5 volts also. Is that okay? I don't know. It's up for your students to figure it out.
Mr. Dwyer, shouldn't it be 5 volts? Don't they use 5-volt references for everything on sensors on cars nowadays? Why is it 2.5? And why is it 2.5 on both sides? I don't know. Let's go look it up. Why? We need to know what kind of sensor it is. And actually, let's do this first. I'm gonna confuse you even more, and this will help hopefully think this whole thing out.
So with the key on, we've got 2.5 volts at the signal pin 89 for the crank sensor. Turn the key off, we just leave it. We've still got 2.5 volts.
I gotta go with the fun hat on this one. Anybody Cardinals fan? Why is there voltage after the key's off? I don't get it. I just don't get it.
Why? And is that ever going to go away, or is it just going to sit there and kill the battery? I presume it's going to go away. Something just happened. Now we're down to 0 volts. So we can ask the students why, ask ourselves why. Why did we still have voltage even when the key was off?
You know, so hopefully at this stage, you know, before you got to the bench, this can't be just total, I don't even know how this system works kind of a class. You have had to go through, you know, sensors, 2-wire, 3-wire, whatever, and had an idea on speed and position, how that works, how you test them and things like that. And the DC volt part, you know, for them to see something like that on a sensor that, you know, we're going to progress to and find out that it's really not a DC volt sensor, is a pretty good discussion. And this, you know, is almost like an assessment at the same time as we're going along. I kind of am listening to the students explain why there's 2.5 volts, period, and on both sides of the circuit. And then again, what's going on? Why is it there even with the key off? And then eventually, why does it die off? And the discussion hopefully would go to, you know, bias voltage, that the computer is testing that circuit, you know, and it's sending out 2.5 volts on both legs. And then the discussion, you know, we'll layer on top of it here in a minute about, you know, what kind of electrons are traveling on that highway, you know, and why do they do this? And so this discussion probably confuses them, but I think it's a good test to test them and kind of see their comprehension, but also to you know, when you're actually going to maybe do a hands-on final and you're assessing whether they understand how sensors work. If they pull out a voltmeter and go to DC volts, you might kind of watch them and see if they really have an understanding. So a lot to be talked about on the DC voltage side. Like I said, hopefully when they got to this point that, you know, that you've already talked about sensors, and they would want to measure AC voltage. So let's take a look at what that looks like. Maybe.
Now I'm going to do a different test. We're now hooking up both of our meter leads to the 2 different wires for that crank sensor. Now that's a 2-wire crank sensor. And if we look at the schematic, you can see it's an inductive type crank sensor, old school style. There's 2 wires, it's going to put out an AC voltage. So if it's working all right, we should be able to turn the multimeter, AC volts, crank it over, and get some voltage. Now we're just getting a little bit of transient, a little bit of random voltage there. If we take the case study out, and we go back to a known good part and we fire this up. We're getting 7 volts, 6 volts AC. And of course, it started right up. Now that's going to depend on engine speed. Depending on the engine speed, we'll get higher voltage. If we go back and put the case study back in, we're back to essentially 0 volts, or very close. We're getting a couple millivolts through there.
So first of all, you saw how easy it is to put that scenario in. I'm going to explain that more later because that's, to me, the key point of this whole product. But and maybe this is out of order, because when I did this class last week for the guys down in Texas, they said the fact that I'm showing inserting the fault and removing the fault pretty well ruled out in their head that the sensor's bad, and I get that. The students may not totally understand that. I mean, we Consulate is good, but we're not good enough probably to make a sensor actually fail. I guess we are, but that's not necessarily how we do it. So when they see it come on and off with a push of a button, hopefully, and maybe that's a smart thing. Maybe their heads are already focusing on the fact that this sensor has a wire going to it, through the sensor and back to the computer. And when he can insert it with the push of a button, it's probably taking the sensor out of the loop here. We probably have a wiring problem, and that's all fine. I want to teach diagnostic strategy, and that's great if that helps them with that. So so now they've measured it. Let's look at this real quick. I guess the lesson on 2-wire sensors, you know, the fact that they understand how that works is where the anchor gets dropped here. So we've done DC voltage, we've done AC voltage. With the DC, I guess with the DC there was a distraction, the fact that there was DC volts on an AC circuit. There's the bias voltage. There was the fact that it stayed on after the key was off, and I probably didn't address that correctly, but it's like the CAN bus going to sleep, and that whole discussion there could be a day's discussion on what's a CAN bus. So now we've got DC volts on and off, and presence, and the fact that the bus controls it. We've got AC voltage, which is a truer measurement. And now they've seen the fact that when the case study is inserted, that there is no AC voltage being generated by that sensor. Now let's go break it down, like I said, in the wire going down to it, the sensor, the wire coming back. And this is where we start isolating. So I'm going to kind of review KG. EGGM, it's circuit 89 and circuit 67. We go to the breakout box and check that.
So let's say that I want to test and measure the resistance of the crank sensor. I got a couple options. So I'm going to take my multimeter, put it on ohms. I can get in here, disconnect the crank sensor, get into those pins and measure it there. And your students can still do that. But we know that students, especially when they're still learning, can cause damage to connectors when they're disconnecting, reconnecting. So there's another way on this trainer because we've got the breakout box. So we can go to the pins 89 and 67. We can measure the ohms of the...
Sorry. The fun part of producing from home is the UPS guy just rang the doorbell and my dog's going crazy. And I tried to mute it and it killed everything. So let's go back.
Let me do that. So let's do that. So we'll connect the one connector, depress the tab, connect the other connector. Now we don't have to go in and back probe at the ACM connector because we've got the breakout box, and the breakout box is permanently connected to the engine harness. So we can see we've got over limit. So we've got infinite ohms. If we turn the case study off, we get 960 ohms, 0.96 kilo ohms, which is dead right in the spec. If we turn the case study back on, we've got infinite again.
So how's that dog coming through for you guys? Is it loud enough? You want me to turn her up a little? Okay, so students at this point in time have focused on the signal wire, the ground wire, and the sensor. We've actually we've really technically backprobed from the computer, but we've done it in a safe student way where we've unhooked the harness and we're backprobing technically from the breakout box. They see the circuits open. We still don't know exactly why it's open and where to go next. So I would ask my students, what do we do? And they'd say, well, let's isolate and check each leg of the circuit. Let's go down to the sensor maybe and unplug and check the wiring coming back. Let's actually check the sensor and then maybe check the wiring coming back from there first. Okay, so let's go do that. Pretty slick, isn't it? Before they go, I'm a big advocate of, if you're going to hook a meter up, you better have some kind of an idea what that reading is going to mean. And so we force them to the service information. They're going to be looking for somewhere between 774 and 950 in ohms. And I guess basically it's great to know that it's at a certain temperature too. So let's isolate. We've measured circuit resistance. Let's actually look at the circuit. At each leg.
So let's say that your students have isolated it. They know there's a problem in the wiring. They've tested the sensor. It's got a good resistance value. Everything's good. And we want them to find out exactly which part of the circuit has got a problem. Well, they can do that. They can use multimeter. Here, we'll put it on a beep since I won't be able to see it. And so we check here. Meter's still good. We'll put this up high so you guys can see. So we'll put that there. We'll go down to 89, which if you remember earlier is a brown wire. Okay. So if I go from the brown wire here on pin 89 and I come over to the harness side.
Never seen a harness ever disconnect that easy in my life, but that's great.
Right, that pigtail, and I go to the brown wire, I got nothing. If I come to the white wire, which we said was pin 67, and I go to the white wire here, what do we got? Beautiful. And now, if I turn off that case study, and I come back to the brown wire, and we check it once more, we're going to see that wire is now fixed. So we've just found the problem, validated the problem, and now we've fixed the problem.
So hopefully that's where we went, or that's where your students, I guess hopefully they understand at this point in time that we've actually broken it down into little bite-sized pieces and we found a wire that's open. On a training car, that's pretty hard to replicate. I had a lot of training vehicles when I was teaching at Oklahoma State, and very hard to replicate a case study like this on a dependable, consistent basis, so that every student that goes through gets the same experience. Usually, I would try and put a bug on. I can go down and actually cut a wire or something like that. They start looking for that more than any kind of diagnostic process. And then the second or third round of guys going through that particular scenario usually are finding things that the first round of guys screwed up trying to get there and left unhooked or disturbed, and so it becomes a very inaccurate kind of way to go. I like this because we can control it a whole lot better. But let's say this is the advanced class and they want to go look at some other stuff. They want to check signal waveforms on this particular sensor. We've already diagnosed it, but let's play. Why not? So service information tells us to go to basically pin 89, which is the KG89, the signal wire on the sensor itself. We're going to do it from the breakout box because it's just cleaner. And we're going to talk about known good first.
All right, so let's pull a quick oscilloscope pattern from the crank sensor. So I've got the scope. We're going to go into 89 for the signal. Sorry, we'll go to ground here. And we'll go to 89 for the signal, and let's fire it up. And give me a second and I'll set up the trigger. So now I've got the trigger set up. We got a beautiful view of that pattern. If I bring the speed up, We can see our frequency changes and the amplitude changes. Of course, we're getting over our trigger point. That's normal. If I bring the trigger up just a little bit more, there we can see different changes in the frequency and the amplitude as I give the engine a little bit more speed.
So hopefully that kind of goes back to where we were checking AC voltage, and they saw the voltage go up and down with engine speed too. And now you're seeing it in a more obviously in a graphic illustration here on a scope, but that they can kind of start seeing how all that works. That a scope is really just a visual multimeter, and that they can see a known good one. So if they were in the field, on an internship or on their own car, or you gave it to them as a test, and they were going to go down and test the sensor, what does known bad look like? So like flat line, like the patient is dead. So I think these engine benches, I think, give you a lot of opportunity to be able to go back and forth and dwell on certain moments and really make sure you have student understanding before you progress to the next level. The distance teaching part of this is hard. I mean, this has been kind of awkward today because, like I said, I expect feedback. I wanted to see your body language. I'd like to see your hands come up, your questions. We would have had probably more discussion instead of me just throwing a different hat on and trying to direct this thing. But I can guarantee you, if you did something like this, from a remote standpoint, you were down at your school, you had a car, and you could control, the faults, or if you had our engine bench, obviously, and you could do this where the discussion is student led and not so much instructor led. Then when they come to campus, and there's got to be time when they're going to come to campus and have some hands-on time. It's better spent. They're better prepared. They're actually, like I said, really kind of anxious to try out their new powers and see if they can do what we did on this video, if they can get these readings, if they can kind of remember, how to get there. From when we did all these seminars this summer, the awkward part or the difficult part was, how do you know that students have even been watching? I mean, I don't know that you guys have even been watching. I mean, I think there's a lot of distractions in this particular medium of teaching, and how do you assess them? How do you know? And again, bringing them back on campus and having them do this and demonstrate that they can do it would be great. But in the meantime, how do we know today that they kind of got it or not? So I don't know. I incorporate little games and stuff sometimes into teaching, and I don't know if any of you all have ever done a Kahoot. I'm going to try here and see if I can do this without crashing everything. Let me back out of this real quick. Maybe not.
Tim, while you're doing that, the voice behind the curtain says, be sure to engage in the live event Q&A. I'm watching that. Jimmy's watching it, and so's Jake, so that we can get questions back to you. So engage in the conversation on the Q&A tab.
And just on the right-hand side there, this is another voice behind the curtain. Like we said, if you got questions specifically for Tim too that you want to engage with his presentation, we can pass that along and interrupt just like we are right now.
And be sure, excuse me, Jake, be sure to engage with the Kahoot too, because I believe Tim's going to show the results of that.
Yeah, it's going to be a delay, but that's fine too. We're going to kind of play with it a little bit ahead of time to demonstrate it, and then I would encourage you all to kind of go in there and do it too. We'll kind of run through it, but for right now, if you'll go to www.kahoot.it, it's going to bring up a deal that looks like this, and then I'm going to provide you a PIN number here in just a second. So let me go back to Kahoot. I'm going to show you what the teacher side looks like. I had this particular game queued up. Whoops, sorry, I'm not on the right screen. There. I had this particular game. Can you see that, Jeff? Okay, I had this particular game queued up to follow this presentation. This is the instructor side. I'm going to hit play. It's going to ask, do you want to do it as an assignment on a self-paced basis, meaning you give it to your students and they have to complete it sometime between now and never, maybe, or we're going to do it right now, and I'm going to do it right now in the teach mode. I was a pretty big advocate when I taught, and I've taught a lot of classes on team-based learning, and the team mode is a hoot. But again, we're, this distance remote thing is pretty much yanked the rug out from underneath me on that. So we're going to go one-on-one. We're going to do the classic deal where it's just strictly your input. So you're at Kahoot.it. I'll take off this silly sound. And if someone, maybe Jamie or somebody, could throw that www.kahoot.it and then that PIN number 54441. I'm going to try and do this from my other computer too and see. Actually, so the students would log on. They have that PIN number. They go to the Kahoot thing, and then I'm going to enter that PIN number 544.
So it's rolled out. It's in the chat. I suspect we've got a little bit of time delay because of the delay here. So you should probably start seeing it rolling here in a minute.
Okay, because I'm going to do it on my phone just to kind of get it going here. I had it set up to have oh, perfect. Had it to where, wow, that's great. I didn't think I'd have that quick of a response. Okay.
One respondent even said it's popular at the collegiate level. So,
do what now, Jim?
One respondent said that even the college students love Kahoots.
So we've been through this whole discussion. It might have been a day or 2, 3 days, something like that. And again, give me a break because I didn't make these questions, super deep. But I like the idea that this is somewhat anonymous, unless there's somebody in your classroom that's really named Bright Piranha. It's pretty much anonymous, and they can answer without the peer pressure, and it helps me kind of continue the discussion or let them continue the discussion. I'm pretty big about student-led kind of things. So now that Yellow Kitten's here, we're going to start and see what happens. You're going to have on your deal just the 4 colors. The question is, check engine lights on. What should be the first test? The answers are down there in colors. You just, on your phone or a mobile device or your computer, you push the color that you think the answer I'm looking for. And the timer on the left is basically just that. It's given us X amount of time to do this. And then when I proceed to the next step, we'll see the results. Cool. So just for my I don't say ego, but I failed here because everyone said clear all codes, and there's no way we said the first thing well, okay, never mind. You're right. There's an interpretation thing here. It was clear codes before we started on this engine bench, so that we're starting with a clean bench. In the real world, if the car came in with that concern, that's perfect. If the car came in with that concern, I wouldn't go in and clear codes. I would read codes. So this is how I find out how difficult it is sometimes to write questions, because I have a son with Asperger's, and he sees everything just absolutely different than I do. And when I said clear codes, I don't mean on this engine bench so that I know we have a clean slate to start with. It would be if the customer came in with this complaint. So read codes is the correct answer, but this is cool. I love seeing this because this tells me probably how I need to make my questions clearer. This kind of talks about, I guess, who was, Anyway, answers. We can analyze the data. Question 2, crank sensor failure. What symptoms did we also observe? Engine stalls, engine oil pressure light on. I'm just going off the chart that was provided in the service information.
Tim, could we address that chart right now in the 12 seconds we have left. There was a guy who wanted to know where you found that chart at.
I think I got those two charts from Identifix, and I pulled down the check engine light code and went to the because I think they're mapping their data based on tech calls for that particular engine light. So this is, again, drop anchor and let's talk. You know, when I was teaching with team-based, you know, these four colors might be four teams, and I would have them discuss. I would have the maybe the red team talk to the yellow team and explain why you chose that. Make them sell the yellow team on that idea, or in this case, whoever answered red, tell me why you answered red and convince me why, you know, green isn't the right answer. I mean, did you really see the engine stall? I mean, you know, and I would go back and run the video, start it up and listen to it. It doesn't stall. So, I mean, we need to clear things up, and this is a perfect spot to do it at, okay? I like the fact that, you know, the majority remember the tach doesn't work. And that was the whole point of that illustration. So let's go to the next one here. Probably a nebulous question too. What type of voltage is best tested for troubleshooting a crank sensor, AC or DC? You know, best would be maybe a debate. It might be a great discussion. Very good. Okay. Looking for AC. We're aware that there is DC. There's probably information to be gleaned off of that. But I think when you're in the field and you're looking for I hate to use the word flat rate because I hate that, but if you're looking for a quick fix, AC is probably your go-to test. And then again, you got to know what you're looking for. Whether you know what kind of signaling can you get it on a multimeter, or you're going to have to do it on a scope. So this kind of gives you a running tally of who's, and in reality, it's a matter of, I think, who answers correctly and who did it in the fastest time too. So you can rise to this, and all of, you know, that was what I really enjoyed about team-based learning, was we got a lot of competition, and that's a good thing. So we'll do a couple more here and then we'll move on. When we measured resistance from KG 89 and 67, what did we have to do first?
And just to remind everybody, we're on like a 10 to 15 second delay. So it's going to lag, your screen's going to lag behind ours a little bit. So just be aware of that.
Yeah, and this is just an illustration. You know, I think you're kind of getting the point here. So, you know, we're getting better. I mean, majority of them say isolate the circuit, and that's a great discussion. I mean, that's where I want to make sure really everybody answers that. But I'd find out why the four that didn't, you know, decided that it was the other test, and try and clear that up before we move on. So let's do the last one here, and then I want to kind of wrap up and then talk a little bit about the student learning platform. So failed crank sensor, always prevent the engine from starting. Did that engine not start after we inserted the case study? So okay, I'm going to kind of jump past this because I think we got the idea. So this brings around at the end, it kind of pulls up the who's first, second, and third. Third place was Smiling Cheetah. Second is Sturdy Otter, and first place is Arctic, whatever the heck that is. Okay, got the idea? Okay. let's do this. I'm going to back out of here real quick. Okay, hopefully just that whole campfire idea is what you walk away from. B, that you would be encouraged to try new things with your students. Don't be intimidated by doing it from a distance. You know, I swear last week with the 20 instructors down in Texas, it was almost like I was in the room with them. We were, it was very controlled. There was good responses. There was good interaction between the attendees, and I didn't have to do anything. I just sit there and listen to one guy explaining to the other why that test probably wasn't going to get you where you were going, or why we were seeing this reading, or et cetera, et cetera. And I enjoy student-led, student-peer teaching too. So try this stuff. Try it with a training vehicle. Try whatever you have to do, but don't be afraid to try. I guess it's, if Council Ed isn't going to teach you anything this week, it's that we don't know, we didn't know what we're doing. We still don't 100% know what we're doing, but we're trying, and it's better than not, or being discouraged by the whole thing. Our students deserve better. The industry deserves better. It's not stopping and waiting on the COVID crisis to be over for us to start cranking out technicians again. Now I want to do something here. I want to show a little bit more about this student learning platform, just because I really, I like how we've done this, how Council Ed has put this together. We started, I've been with them 6 years now, and I like working with them because they listen, and they said dream big. So when I first started working here, we had engine benches that had manual fault boxes, little toggle switches, like we put on the dash of our old, race car, and they're great. They insert a fault into a car, into the engine bench, and the students have to diagnose it. They have the same breakout box and things like that. Then we went to an electronic programmable box that was a little bit more user friendly. Had buttons and that you could go down menus and scroll through and select things. You could save it. You could put in really all of our, at that point, we could start putting in single, multiple, or intermittent faults onto an engine. That's kind of opens up a lot of discussion with students when you're chasing more than one problem. You can put in intermittent ones, which is, we know as technicians, most of us are all former technicians. The scourge of the business is the intermittent fault. And then what I liked about that was that you had the box and the physical buttons, and then they put in a USB port, and we designed some software that basically brought that box up to your laptop. So you would, as an instructor, turn the fault box on, plug in with your USB cable, put the software from our website onto your laptop, and be able to insert a fault from there. So I could come up in the morning, turn the fault box on, shut the fault box door, lock it, and walk around with my laptop and plug in, put a fault in, unplug, and walk to another bench or walk away and let the students diagnose it. There was times when there was instructor-led moments where I'd put together something and we'd all discuss it. And it wasn't necessarily a bug hunt. It was a discussion of what if this failed? What does it do to the engine? And we'd have these great discussions. And with the electronic programmable fault box, we could save those scenarios just like a file on a document. You pull up a save, you put a name on it, second period, crankshaft position sensor lesson, save it. And then you clear it back out of the box, so the next instructor's got a fault-free engine bench, and you go on. You can put that same fault back in it the next day for the afternoon class, for the class next year as a final exam. We were doing skills contests where we were layering multiple faults in there, and then as the students or the contestants got to where they figured something out, we'd plug in, take that fault out, unplug, and walk away. And so they were kind of like finding and fixing and going to the next one and working their way through, and it was great. It worked really well. It still does. The next, I think the evolution of this SLP was because as instructors, we're on the ground a whole lot more now than ever, and all of our education team has walked into a school at one point in time with an engine bench and seen the USB cord coiled up in the same place it came when it was bought, still in the bag, maybe in a file cabinet, and the instructors have never even loaded the software. They don't use the fault box like it's designed, and we'd rather not even be in business if you're not going to use our stuff I mean, it's that we're that serious about you learning. We put a lot of thought into these things, and we want it to be used to its fullest. And shame on us maybe for not educating you on the potential of this stuff. So when we were told to think big, how would we make that even easier for instructors to use? And so we come up with this touchpad because we all live on our phones. We all live on pinch and zoom and being able to use electronic devices. And so we put this right into the dashboard of the engine bench, and it's got 2 layers, and it has student-led and instructor stuff. So we've given you a ton of information because as we design things to train with, we really are, I think, pretty conscious about trying not to make more work for the instructor. It's got to be easy and intuitive, and otherwise it does have a tendency of being sitting in the corner because you guys are busy, and I understand it. Now you've been dealt a whole nother hand of learn how to do this virtually, and you just don't have time to learn how to use something. It should be easy to use. So we put these blue boxes in here, and they're student-led. You can go up to, let me hit a couple just boxes here and show you. The operation manual, we put it in there, a PDF version, so the students can go through and actually learn about the bench. And that's a lesson in itself. I'd want them to know everything about it, how to leave the charger on when you're running it, how to hook the exhaust up, what the battery charger does, the fuel system, safety, all that kind of stuff. I mean, we need to do that before we even touch the bench. They have access to the breakout box, so it's OEM service information. Again, they can pinch and zoom. They can pull it up and look things up, look for pin connectors, and the breakout box on our engine bench, like I said, follows factory service information. We've taken all the wiring diagrams and put it in one button, and I'll show you where they can get to that again at a different spot. And just like I said earlier, we can pinch and zoom with clarity. This is maybe not as clear for you because I'm using an app that allows me to display an Android app onto my Apple computer here. But I'm telling you, when you're looking at it on the engine bench, it's crystal clear. And we tried to do a lot of this stuff so that this bench had information for the students, but it didn't necessarily have to be hooked up to the internet because a lot of campuses are pretty proprietary over who gets onto their network. So we gave the students most of the information they need right at their hand. There's a component locator, again, probably part of the ID thing that you would want to do with them. And again, a lesson in itself, perhaps. But so here's, I think where, as Nathan said, the rubber meets the road. You're busy, or you've got students coming. Maybe now the new look is you have a few students coming on campus at a time, and you're trying to keep them apart and keep them distance. You put an engine bench over here, you turn it on, have the battery charged, full of fuel, ready to go. You give Johnny the repair order that says case study CSO2, like we just did, the crank one, and you tell him to go over there and do it himself. He walks over and he pushes the case study button. He sees this menu of 7 of them. These are pretty much student-led exercises. He would push CSO2, and it describes just what we talked about earlier. Check engine light on, extended crank, clear all codes before beginning each case study, follow OEM troubleshooting sequence, use the documents that you can see, little shortcut tabs right down here at the bottom, so that they can explore and hook the scan tool up. See if they can follow data that'll lead them to the root cause of the particular case study that you've inserted. And then, of course, when they're finished, clear the code so that the next guy gets a good experience. And the green button, they just push, and it needs to be connected to the bench. Otherwise, it'll say it's not. And I found if I push it now, it'll kind of lock it up. So I'm not gonna. But generally, that's all they do. You saw Nathan do it in the videos that I'm showing you. So it's that easy. They're on their own. You're not even near them. And then they come back and report back to you. You have basically a repair order form that they have to fill out. And I'll show you. We've got information, I guess, that goes along with this that would give each one of these case studies some type of document. So let's go back real quick to, that's the student side, and that's unlocked pretty much all the time. You as an instructor have privy to a whole lot of a more enhanced version of this whole thing, and I'm going to show you real quick. You have a PIN number. God, I can't believe I remembered it. Okay. And there's actually a key on the face of the instrument cluster that you could walk up to and unlock if you don't want them to see your PIN number. So you have an instructor guide, which gives you a little bit more information than the operation manual. The wiring diagrams with faults, I would show you that, but I'm not gonna because we're recording. And if I open that up, then basically somewhere on YouTube, all the places that we've inserted the faults are gonna be available. And I want that to be just FYI for the instructor. But my point is, when you pull up a particular case study, you have access to our wiring diagrams as to where we put the faults. So you know exactly what, where the students are gonna find this stuff at. But the cool part is the case studies. Okay, they get you share the first ones with the students. Those first 7 are similar, but you also have access to all these other ones here on the side: ECT, IAT, the map sensors, CVVT, accelerated pedal position, and let's go back to the one you're familiar with first for 2 reasons. I'm going to go back to the student-led one, that's CSO2. This is the same one we just did the presentation on, but you have more enhanced information. In this case, we open the crank signal between 89 and the sensor pin number 2. See the fault diagram, and it's here again, a shortcut right at your fingertip here. The engine will start, be a long crank. The light will come on after 2 cycles. Your students will find a PO 335. And you can diagnose and follow manufacturer's procedures. Also, look, the tack will be enough. So you've got the inside track. You know things now. You haven't had to go up there on your own time or after hours and go through these case studies and try to figure out what the students are going to see. You've been kind of given the cheat sheet, and it makes it really handy. And one last thing before I hand this thing back over is, you see in this where right above check engine light it says scenario number. So there's 4002. Let's just remember that. We're going to go back to the home, and you know how students talk, and you've given Johnny case study 02, and then you gave Billy case study 02, and then they pretty much all realize that that's a crank sensor. And so you've got a final exam coming up, and you want to see if they really do know how to go back and find a crank sensor. But if you give them case study 02, they're going to remember it. So you give them a scenario number. So you go in and you hand them just a repair order and tell them to go type the scenario number into this button instead of opening up a case study, and it takes them to whatever scenario you give them, but they don't know which one it is. They have to actually remember, or they have to diagnose it, perhaps according to memory, hopefully, but it's not going to be like they remember it is the crank sensor because it was case study 02. So that's my spiel. I love this feature. I like the fact that the students are somewhat autonomous in a lot of cases. I like the case studies that the instructor, I feel like they're pretty much instructor-led studies. They shouldn't probably be given to the student alone. They should be done as a campfire where you bring them up and actually put something in and maybe talk about what do you expect when we put this in there, and let's see if it does it. And let's go back out and take it out and let's check this. And I mean, just the back and forth curiosity and discovery is priceless. So I think I have rambled for my entire time. I hope you guys are encouraged to try new things. I hope you like the bench, in all honesty. I mean, that's kind of a side effect. Hope you try Kahoot. I hope you just try new things to keep your students engaged, because like I said, our industry is counting on us not to fall down on the ball even during this time of distance learning. And I really feel like this is an opportunity sometimes to reboot. There's maybe some stuff that we have been doing that hadn't been quite as efficient as it could be, and we're going to have to tune it, and we're going to come back stronger than ever. So thank you for letting me lead this thing off. I don't know if it was a home run, but I feel like I got on base, and I'll hand this back over to the wizard or whoever's running the show. Unless they fell asleep.
Should be Jake.
Unless they fell asleep and they were leaving me.
Jake or Jimmy.
I mean, I'm here right now, so there was some good interaction in the chat, or in the Q&A. This format's still new to me too.
Yeah, I feel lost.
A couple general questions that I can answer. Somebody said, hey, if I already have an engine bench, can we retrofit that awesome student learning platform onto it? Unfortunately, the answer to that is no. It would not be cost effective. By the time you ship it back and we get it all retrofitted, it would have been more expensive than just getting a new one. So unfortunately, that is not possible. There was questions about the certificates and the sign-up sheet for this presentation. That is sitting in the Q&A right now. The link is also up on Dactic's website. As Jake pointed out, you can request your certificate for attending this one. I think that was all the general questions that I wanted to get to. Jake, if you're there, you can take it as well. Anything else you want to?
I am here. I missed the question though. I was responding to some emails from people trying to log in here.
I'm going to quit sharing.
What's that?
I'll quit sharing and let you turn control back over to you guys.
Jimmy, what was the question again?